In this video, we'll delve into the if function, exploring its various aspects and capabilities. Specifically, we'll cover the fundamental concept of an if statement, how to effectively employ it with conditions such as and or, managing multiple if statements, and navigating optimization strategies along with potential pitfalls. Let's illustrate the concept of the if statement with an example. Imagine we want to classify individuals as either children or not children based on their age. We define a child as someone aged 12 or younger, so we'll check if a person's age is less than or equal to 12. If it is, we'll label them as child. In the timeline below, we've depicted various ages, highlighting those who meet the child criteria in blue. Anyone not meeting this criterion will be labeled as not child, depicted in purple. Now let's clarify a couple of assumptions. Firstly, we assume that ages in our dataset are always non-negative values, even though we display negative values in the timeline below. Secondly, we assume our dataset only contains integer values, ensuring we won't encounter ages like 12.5 years old. When we work with if statements, we can also use them in the opposite way. We can first ask ourselves if the age is greater than 12 years old. And if so, we're going to label them as not child. Otherwise, we're going to label everybody else as child. And at the bottom, we can see that we still have the two options as before, where we have created two categories. Now let's explore the if statement with an and condition. Suppose we aim to determine whether someone is a teenager. For this, they must be strictly older than 12 years, but younger than or equal to 19 years old. We'll identify individuals meeting both criteria as teenagers. Let's first highlight individuals older than 12 years in the timeline. Next, we highlight those aged 19 or younger. We observe an overlapping region for individuals older than 12 and younger than or equal to 19. This overlapping area represents teenagers. Utilizing the and criterion, where both conditions must be true, we classify individuals in this area as teenagers. Those not meeting both criteria are labeled as not teenagers. We can consolidate these classifications into a single chart at the bottom. We can also utilize an if statement with an or condition. Using the same example of labeling someone as teenager or not, we first ask if anyone is aged 12 or younger or older than 19. If they meet either criterion, we characterize them as not a teen. This is depicted in the timeline below, where we initially display individuals aged 12 or younger, followed by those older than 19. Notably, these groups are mutually exclusive. Anyone not falling into these categories is classified as a teenager. Consequently, we observe two distinct sections, one for teenagers in purple and another for non-teens in blue. Additionally, we can employ multiple if statements. For instance, we can initially inquire if anyone is age 12 or younger. If affirmative, they're labeled as children. Subsequently, we pose a second question. Are there individuals aged between 12 and 19 years old? If so, they're categorized as teenagers. Everyone else is designated as an adult. This approach involves creating three criteria, but the classification can be further refined. For instance, adults can be subcategorized into early adults, middle-aged individuals, seniors, and so forth. An optimization strategy can be applied to these types of analysis. For instance, instead of checking if someone falls between the ages of 12 and 19 after identifying children, we can directly ask if they are 19 years old or younger. In theory, anyone younger than 19 would meet this criterion. However, since we've already classified those under 12 as children, the only individuals left to consider are those aged above 12, who would then be labeled as teenagers. everyone else would be classified as adults. This approach condenses the classification into 3 groups, streamlining the process. When employing these optimization techniques, it's crucial to avoid a potential pitfall that arises from altering the order of the if statements. For instance, if we first ask whether someone is 19 years old or younger, and classify them as teenagers accordingly, then proceed to ask if those not classified as teenagers are 12 years old or younger, and label them as children, we encounter an issue. Upon closer inspection, we realize that if everyone aged 19 or younger has already been labeled as a teenager, no one remaining qualifies to be labeled as a child. This occurs because those under 19 never reach the secondary if statement due to their earlier classification as teenagers. Consequently, everyone else is automatically categorized as an adult. Upon review, we find that only 2 classifications are present, teenagers and adults, with no individuals classified as children. In summary, this video has provided an in-depth understanding of how the if statement functions. If you found this tutorial helpful, please consider subscribing to the channel for similar content. Feel free to leave a comment suggesting any other topics you would like us to explore in future videos.